Okay, so let's go through the exam, and then we'll see where we uh, are on time, and we'll start going over some other stuff. First of all, exams are actually pretty good as a whole. One thing I'll remind all of you of is programming is hard, and I said that you were going to suck for a while, and I have the policy that if you did poorly on the midterm and you do better on the final, I'll replace whatever you got in the midterm with what you got on the final. So if you did poorly on the midterm, that's okay, as long as you explain why you did poorly. If it was lack of preparation or you didn't take it seriously or something like that, well, then you need to adjust your behaviors moving forward. If you've been putting in the effort, things just haven't clicked yet, then you're right where you need to be. Okay? So do a self-assessment there, but as a whole, the grades were actually solid. So here's the grade breakdown. Their lowest grade was a 39, highest was 100. Class average was an 85. It's probably skewed, because there were several very high grades, and that's going to skew maybe some of the lower ones. So there were 13 A's on it, 7 B's, 1 C, 2 D's, and then let's call them a couple of others. So a lot of folks did fairly well on the exams. All right. Now, I did have, you probably noticed I had to take a couple different interpretations of one of the questions because Blackboard messed up my spacing, my indenting. So everything was left justified in my code that I gave you, so I accepted a pretty wide range of what that might have done, as long as it was within the realm of reasonable, but is what it is. Okay, so let's go through the exam, and you can ask any questions, and I'll try to show you a couple different versions of some of these, because there were some fairly interesting responses to a couple of the questions. Some of you might have might have written a note on your test that this technically works, but this is weird, or something like that. I would have never thought about solving it that way, but it worked. So I'll, assuming I remember as we go through it, I'll point some of those things out. Okay, so let's just start with number 1 here. What does it mean for Python to be loosely typed and interpreted? First thing, the most missed on this was test taking skills. Make sure you answer all parts of the question. All right, so what does it mean for Python to be a loosely typed language as well as an interpreted language? There's 2 pieces to that question. Okay, so make sure you answer both of them. There was plenty of people who obviously knew what they were talking about, but just omitted the second half of the question. All right, so when we say loosely typed, what we're really talking about is that Python does not require us to define the type of values our variables are built to store. Now, a fairly common question that I knocked you for a point or something, or a common answer was, does it require you to define variables? Now, that is technically true, but for a different reason. You can just use a variable out of the blue that you've never predefined, because you can't actually predefine a variable until you're ready to put a value into it. Okay, but loosely typed specifically indicates that when you create variables, you don't have to specify what kind of value goes into them. Now, some people could have elaborated on this and said things like, well, you can store a number 1 second and a string another second in the same variable. That's all true and all related to loosely typed, but at the core, something along these lines. All right, interpreted. So this means it's relatively slow. converted to machine code at runtime, something like that. And then I guess you could have elaborated on that and said things like the interpreters are easier to write, so that's why we have more interpreted languages than we have compiled languages and things like that. But at the heart, something in this ballpark. All right, 2. Convert 1001101 binary to decimal. 100 111 01. All right, so that guy from binary to decimal. So this is the pattern where we have to keep track of the places, right? So this guy's the ones place, 2s, 4s, 8s, 16s, 32s, 64s, 128s. So this is a 1 times 128 plus 0 times 64 plus 0 times 32 plus 1 times 16 plus 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. And that's 157. All right, questions on that one? Okay. Next one, convert 1328 from decimal to hex. So 1328 decimal to hex. So this is the other pattern, right? Where we divide by 16 over and over again. So we're going to divide by 16. So this is 1328 divided by 16 gives me 83 with remainder of 0. 83 divided by 16 gives me a 5. 5 times 16, so that's a remainder 3. 5 divided by 16 is 0, remainder 5. Let me read the answer from bottom up. So this is 530. So it was actually easier than it should have been. I should have had a letter in there or something. But it's hard to come up with good conversion things when you're just picking a random, somewhat large number and just hoping it's good. I mean, the only one I know is the 2989 because that's like my favorite, the BAD one. So I teach with that one very often, so I know that number. Otherwise, you're just picking a number out of the sky and hoping the remainders come out right. Right, so the answer to 3 was 530. Now, let's assume that we had something in here like a remainder of 13. Okay, we would have had to convert that 13 to the letter, right? A is 10, B is 11, C is 12, D is 13. So if that was the case, it would have been 5D0. If I had given you an example that gave you a remainder 10 or greater. That make sense? So there was potentially a second piece of that in the pattern that you didn't have to use in this question, but it was possible. All right, questions on that one? Too bad. And again, I think I even wrote it in the question. Show me your work. I realize typing might be a little weird. Some people like attached a picture to it. Some people even emailed me a picture of their handwritten work or something, which is fine. Because if you just give me a number with no context, I mean, you might have gotten, you might have gotten it 90% right. But you made one little math mistake. In fact, I kind of remember a couple people. I don't know if it was in this one or this one. One of the two. Where they did all this math. They had everything you see on the screen here. Except their final answer was that. They just said 53. They got it right. They just didn't copy their answer down right. Right? I mean, if they had literally just said, okay, well, I'm not going to do this, I probably would have given them a 9 out of 10 for 530. They didn't know which direction to write it or something. But if they're starting to write it in the correct direction, they just stopped copying their own answer. I didn't take off points. I mean, that's just, I think I might have said like LOL in my response or something, but. All right, so I do look at the work, especially when you have an incorrect answer, and I'm trying to find out did this person know which pattern to use? Did this person know what they were doing and just made, a test anxiety, stupid math error or something like that? Multiplied 1 times 5 and got a 10 out of it or something like that? I'm pretty sure you know what 1 times 5 is. So, but on an exam, anything can happen, right? Okay. 4, write the necessary code to display all the numbers, all the odd numbers between 1 and 100,000. Now, you can make a little interpretation of whether this is up to and including 100,000 or not, but good thing for us is that's not an odd number. So, it didn't necessarily matter. So, the simplest version of this, I'm going to go ahead and write it in Atom so it indents it reasonably for the answer. All right, so first of all, I just asked you to write code, not a function. Now, if you had written a function, that's fine. That's technically code. But the other direction, several of the other questions in the exam specifically asked you to write a function that takes some number of parameters and does something with them and either returns it or prints it. All right, so you did lose points if you did the wrong thing of those two. I want to make sure I'm driving that point home, the difference between printing and returning. So I'll talk about that more here in a few minutes. But for this one, you didn't have to write a whole function, just some code that prints out all the odd numbers between 1 and 100,000. So this is probably going to be a loop. We're going to do some repetition. I assume you did not want to have 100,000 if statements, or I guess 500 or 50,000 if statements, or 50,000 print statements rather. So for I in range 1 to, now we'll just go to 100,000 like that. Now, probably the most convenient answer to this would be just say step by 2. 1, then 3, then 5, then 7, right? And then just say print I. So this will print out all the odd numbers between 1 and 100,000. One issue I saw several people do, they had all the right code, but they just wrote like 1 to 1,000 or 1 to 100 or something like that. I thought that was weird too. Like, I mean, that should be the easier part of it, but anything can happen during tests. I've seen some crazy stuff. Okay, so does this solution make sense? Yeah. We know the odd numbers are 1, then 3, then 5. You start skipping by 2, so we'll start at 1. We'll go all the way up to, but not including this dude, and we'll skip by 2s. Now, some people maybe wrote your default loop, something like that, and then each time through here they asked a question. They said, if the current value of I, when modded by 2, if that equals 1, that means it's an odd number, then we will print out I. That's fine. We're doing a whole bunch of extra question asking, but this is accurate. In fact, this shows me you understand how to test for even or odd. The other one just showed that you didn't have to test for even or odd since you happen to know that it's a consistent pattern. Another alternative to this, you could have said not equal to 0, which is the same thing as saying equal to 1 for testing even or odd. Because if you mod anything by 2, your possible results are 0 or 1, right? So your toggle here is this is going to be a 0 or this is going to be a 1. If it's equal to a 1, it's odd. If it's not equal to a 0, it's odd. All right, questions about this one? Okay, and let's see. Let's just go back to my, I'll put the convenient answer in here. Let's see how well this pastes into Keynote. I'm gonna go out on a limb and keep my expectations real low. I think if I paste it like that, that's not horrible. I think we should just sit on that. It's going to get weirder when we have 3 lines, or we have more than 1 line. I bet you if I left justify this, it's going to, will it put everything all the way to the left, or was, that's good.
Add the step to the...
Oh, thank you. I didn't control Z enough times. Steps of 2. All right, questions on that one? We're good? All right. Let's see here. How does Python represent the following ways humans solve problems? Memory, asking questions, repetition. No excuse for missing these. If you missed any points on this, you didn't prepare for the exam. Especially since I went through the slides and I specifically said this will be on the test in some way. And I think I repeated that kind of cadence of those 3 things 1 to 5 times per class, something like that. And just to give you some structure on this, this guy right here, this memory, asking questions, and repetition is actually the foundation that we teach all programming classes on top of. You will hear the other teachers talk about this same pattern over and over and over again. It's the way I teach programming. I've been teaching it for a long time, but I mean, this isn't rocket science. This makes pretty decent sense, right? But this is a really important foundation piece for how does computer science work? We rely on computers to kind of, mimic in a small way what we are capable of doing. You can't keep up with it. Computers are dumb, but they're just not error prone like we are, and they're really fast at doing simple things. But this is an important concept, even though it maybe seems kind of trivial or not mathy or something like that. Okay, so how do we're on 5, right? So we have memory, that's variables. We have asking questions, that's conditionals. You could say if statements. And then we have repetition. And that is, loops would have been enough. But when I teach this originally, I say loops and functions. Kind of those reusable chunks of code that we can call multiple times. But if you pretty much said memory is variables, asking questions as if statements, and repetition as loops, you showed me that you understand how the language breaks it down. All right, questions on that one? And like I said, if you missed any points on that one, really reevaluate how you prepared for the exam. And did you forget you had an exam, or did you blow it off? Spring break started early, whatever it was. Just make sure you come up with a actual rationale on why you didn't do poorly, why you did poorly on that question. Go ahead.
Is there a way to actually see our submissions? I mean, it shows, I see the different ways that we have for each question, but it doesn't show us our actual submissions.
I don't know. I would assume yes. But I haven't tried from that side.
Yeah, I can show you what it looks like.
Okay, if you want to come up afterwards, we can take a look. But does anybody else know? Are you able to see your... Interesting. Okay, so it sounds like you can't necessarily. If somebody just throws something up on Slack just right now, I can see if I can run some sort of report or something. I don't know. That would be a pretty big flaw, it seems like. Yeah.
It's the issue with one of my other chemistry
Well, yeah, I mean, Blackboard lets you deliver exams that way. You would think as a student you should be able to see your answers.
It should work. Like, I had a professor, he corrected our exams, and he gave us, like, this hints and whatever.
Well, right. So when he corrected, he print them out and then.
You put them back on black or whatever you want to see it. Like I could see what I.
Okay, so he had some sort of way of showing you your responses.
Yeah.
Okay, somebody just put a message up on Slack, and I'll read it this afternoon, and I'll try to find that button. It's probably a it's probably a checkbox or something like that. So if you're telling me it exists, so I know what to hunt for, I'll Google it or whatever. Yeah, I didn't even consider it when I was going through. Sorry about that. Okay, so 6, write a function. So right off the bat, as soon as you see the word function, I'm asking you to write a structured function. Something that has a name, something that has a parameter list, does some things, and then probably either displays some stuff or returns some stuff, or it might just do some mathy stuff, but if it's not displaying or returning, you might question why it's doing it. Maybe it's writing to a database or something, but in our world right now, we have two options. We either have our functions spit some stuff out to the screen, or we have our functions return a value so some other part of our program can use that value for something else, including possibly printing it out. All right, but right off the bat, I said write a function. That should tell you that I'm asking you to do more than just write generic code. All right, write a function that takes a string as a parameter and returns the number of spaces in that string. Okay, this was the one that was how some people solved kind of weirdly. All right, so now we're returning the number of spaces in that string. So we are counting spaces. Counting spaces. So we'll say we'll say count spaces. You can name it whatever you want, but that's a pretty decent thing. I'll take a string named S as a parameter. We're going to go through every character in that string. I'm probably going to keep track of a count. I haven't found any spaces yet. So count will start off at 0. I'll say for I in range of 0 to length of S, if S at bucket I is equivalent to a space, count is equal to count plus 1. So go through every element of my string, ask if the current element we're looking at is equivalent to a space, add 1 to my count. Do that over and over and over again until I run out of characters to check. In the end, return the count. Does that make sense?
Yeah.
So I'm going to copy this because I would say this is probably the cleanest solution. One interesting, and more than one person did this solution. They maybe had something like an answer, and then they said if I'm looking at a space, we'll say answer is equal to answer concatenated. Well, you can, with a space, something like that. And then what they did is they returned the length of answer. So effectively what you did is you removed everything that was non-spaces, leaving only spaces, and then said the length of the thing containing only my spaces is the number of spaces. It's accurate. Nothing wrong with it. Kind of interesting solution. Just I wonder how you came up with that. Like, well, I don't necessarily really wonder how you came up with it. It's the idea is that you took one of the patterns that we had from our functions that we've written in class several times, where we had kind of an answer, we built up a string, that kind of stuff. So when you dove into this question, you thought, oh, maybe this is a building up a string question. You started with that and you say, okay, well, what do I manipulate here to change stuff? So this is fine, but do you see how this is kind of a wonky answer? It's not wrong. I mean, it's fine. It's kind of a really, I don't know. Yeah, whatever. It's a thing. It is a thing. All right, questions on this one?
No, that makes more sense.
All All right. Now, you didn't need to show me that you could call it, but if I were going to call this guy later on in your program, you can say something like num spaces is equal to count spaces in hello world, LOL, something like that. And then if you really wanted to then print num spaces, you could. Okay, so this function here goes through and counts the spaces and then returns that answer to whoever called it. I am choosing to take that answer that was returned and I'm storing it in a variable. And then I happen to go ahead and print out that variable. But this is very different than saying print that here. Because if I say print inside of count spaces, what's going to print here is the number of spaces. Num spaces will then be equal to the value none, because this guy doesn't actually return anything. And then I'll print out none, because it's like a null value. It's a function that doesn't return anything. There's a distinct difference between printing something and returning something when we're talking about functions. If you want a function to do something and provide the answer to other parts of your program, you want to return. If you want to just display the answer to the user on the screen, not to be used again, you can print. Make sense? All right, so I'll put that was 6. So there's our, I assume I can make that. So there is count spaces. 7, write a function. Again, it's a function we're writing, so I put you right in that mode. I'm going to write, it's going to be name, parameter list, that kind of stuff. All right, so write a function that takes a string as a parameter and returns that string in reverse. Okay, now we had previously written this one in class, but an important thing here is I was not asking you to memorize something we've written in class. You shouldn't go through and memorize functions. Okay, it's not going to get you anywhere. All right. You want to be able to write the functions by hand, just problem solving. Now there were some kind of weird answers to this one too, where you tried to play like the math game and only reversed up to a certain point. You kind of went like halfway through the string and that kind of. So I'll just show you what seems to me to be a pretty clean answer. Let me just give you some space here. So we'll say def reverse. This will take a string as a parameter. What I name this guy doesn't matter. I can call it elephant if I want. Just whatever I name it, I have to call it by the same thing inside of the function. So taking a string s kind of makes some reasonable sense. I'm going to build up a new string, which is going to be the reverse of the old string. And then I'll say for I in range 0 to, now you can do this a couple different ways. You can go forwards through it and build it in reverse, or you can go backwards through it and build it forwards. Don't do both of those. I'll show you all 3 versions of this, right? So I can go forwards through the string, but build it in reverse. I'll show you that one first. Okay, so this is our standard loop that's going to go from bucket 0 to bucket 1 to bucket 2 to bucket 3, right? But what I'm going to say here is I'm going to say answer is equal to s at bucket I concatenated with answer. I'll build it backwards this way. So each time through, I'm tacking on the next character onto the front of it, which will build it backwards. In the end, I'll return answer. So, one possible solution. Or you could walk the string backwards. So I would start off at the last legal bucket, which is the length of s minus 1. Go all the way up to, but not all the way down to, but not including a -1. Taking steps of -1. But in this case, you're going to build it forwards because you're walking it backwards. So far, those two solutions are equivalent to each other. Make sense?
Yeah.
One of them, I walked the original string forwards. I just took each character and kept tacking it on front of the one after it, effectively building my answer in reverse. This one, I start at the end, walking my original string backwards, just tacking the characters onto the end, building it in reverse. The waste of time solution is when you combine those two. When you say, I'm going to go from 0 to the length of S, stepping by your normal 1. But we're also going to build it. Actually, well, this does the same thing, but I'm actually going to go backwards because the backwards one looks like it should be correct, but it's not correct. So we're going to go through our source string in reverse, and we're going to go ahead and we're going to build it. In reverse, which effectively builds it forwards. You walk it in reverse, build it in reverse. What you have in the end is what you had in the beginning. You didn't do anything with it. But it looks legit in the middle. Like, look, this is some code that's doing something that results in nothing. All right, so probably the, I need to throw a parenthesis here. You can pick your poison on which of the two first ones that you like. If you're comfortable writing this for loop, where you start at the last legal bucket, so you're comfortable saying the last legal bucket is the length minus 1, going down to but not including -1, taking steps of -1. If that is what you're comfortable writing that loop, this is probably the most comfortable solution. Saying, because this pattern is identical whenever we're building up strings, right? I'm going to take my answer I'm building up, I'm going to set it equal to whatever it currently is with something else tacked onto the end. So in that case, it was important that we walked our original string backwards. If you don't like doing these reverse for loops like this, you can go the other direction. So here, I'll go ahead and copy this one because this one looks reversey, all right? But if you would rather go through, have your stock for loop that goes through your string normal, then you have to know that I'm going to build this guy in reverse. And there seems to be almost like a little, it's not a trick, but it appears to be somewhat of a little hidden trick in that line of code. That I'm tacking the guy onto the front and that's doing something. So this is also correct. I'm walking it forwards but building it in reverse. All right, questions about that one? Okay. All right, so something like that. All right, what does the following function do? And I said, give an example of sample input and output. And if you remember, when I talked about these in class, I think I wrote it on the exam as well. I don't want you to just tell me what each individual line does. I want you to tell me what this code as a whole does. If you want to tell me what each individual line is accomplishing, that's fine. But I want to know what problem this chunk of code is solving. All right, so obviously a mysterious method name so that it doesn't give away too much about what it's doing. So this guy's taking, now since we're in a loosely typed language, just because this guy's named S, we can say, well, it's probably a string. It's a loosely typed language. We don't know what it is. So we have to kind of infer what it might be by how the rest of it is being used. All right, so now I have this variable a, and started off at 0, so that's numeric. I have a for loop that's going to go through all the elements from 0 to the length of s, so that tells me that s now is a collection of something. So in terms of what we've done in class, it must be a string. In terms of what you've done through the book and stuff like that, it could be a list as well, right? Okay, so this is a collection of something. Each time through, I'm going to say a is equal to a plus. Now, since a is a numeric type, the plus sign is going to be a arithmetic. It's addition, right? And what am I doing? I'm taking the integer version of whatever I'm currently looking at in my string. Okay, so if I had the string 1, 2, 3, and I was currently looking at the 2, it's going to take the character 2 and it's going to convert it into the number 2. I will then add that to the front of my, I'll add that to my running total, rather. So in this case, this code here sums up the integer version of all the characters in the string. So that's number 8. So we can say this sums up the integer version of all of the characters in the string. So for example, if I had the string 1, 2, 3, this would give me a 6. The number 1 plus the number 2 plus the number 3. All right. Now, I don't actually think anybody answered it, so let's call that my intended answer. I don't think anybody actually answered it this other way, but what if I had something that was like ABC? So let me actually test it real quick, because I'm not sure what Python will do for the character A, but I suspect it's going to give me the numeric Unicode value of it. Here, I'll just do it out here at the command line real quick. All right, so we're going to say S is equal to ABC, and then I'm going to say print the int version of S at bucket 0. Yeah, so it's with base 10, it's not going to like that anyways, but it looks like there's a version of int. So print int S at bucket 0. Can I do something like that? Yeah. So it'll there's a version of int that lets me tell it the base. It's actually interesting that it wouldn't convert it, so it's good that nobody gave that answer. But I would have probably accepted that answer, because many programming languages will do that, because if you look at how characters are stored, they're actually stored as numerics, because you have this giant Unicode character set that maps everything. So, you know, a 1, a 2, a 3, these guys have Unicode values. Well, a Z has a Unicode value. A question mark has a Unicode value. These guys all have some numeric types. And so technically, this answer here is pretty accurate, where it sums up the integer version of all the characters in the string. Whatever that means by integer version of the characters in the string. It looks like in Python, it assumes it's a string filled with numbers. But in other languages, if you had something like this, it would take the Unicode value of A, add it to the Unicode value of B, add it to the Unicode value of C. Out of curiosity, real quick, I want to see if, no, it's not going to, can I do, yeah, it won't pull it back out from a string type. Yep, so we're going to call this the accurate answer. Something like that. technically, if you treated this as a list, or that would have been fine too. Wasn't my intention. We didn't talk about those in class, but you definitely read about lists. We're going to be dealing with lists a lot the second half of the semester here. But punchline is, when we look at the code here, this guy is clearly talking about some collection type, because we can only take the length of collections. All right, questions about number 8? All right, number 9, write a function that takes 2 integers and returns the larger of the 2 integers. Again, write a function. So that immediately puts you in the mode that you have to write this reusable chunk of code. So we're going to call this guy find larger or something like that. And this guy's going to take in 2 numbers, maybe a num1 and a num2. That's the parameters. If num1 is greater than num2, return num1, else return num2. All right, so again, we go back and look at the question here. Takes 2 integers and it returns, doesn't display, it returns the larger of those 2 integers. That might be something that is useful in other parts of your program, where you're given 2 values and you want to know the bigger of those 2, rather than writing a zillion if statements in the middle of your code. You just have this little function you just toss it to and says, give me the larger of these 2 values. Go ahead.
Wouldn't that return num2 even if they're equal also?
Is there, if you have 2 numbers that are equal, let's say it's 5 and 5, does it matter which of the 5s you return? Yeah. But operating off that, a lot of people wrote that. So, but I would ask this question. So you might say, elif num2 is greater than num1. You would return num2. Then all of a sudden you're in this like weird position where you have this else. What am I going to do? Well, what a lot of people did is they print they are the same or something like that. So in this case, if you're in this else, this function returns none. It's fine if you wrote all the rest of this stuff, but just had this like weird extra thing I didn't take off. Okay, but understand that if we're dealing with numbers, all variables resolve to their most local definition, right? So if I passed in a 5 and I passed in a 5 for num1 and num2, at the end of the day, I'm dealing with 2 5s. It doesn't matter which of those 2 5s I return, a 5 is a 5. So if I say, find me the larger of these 2 values, and I pass it 2 5s, let's say the larger of those values was a 5. Cool. Make sense? You could also write this if you wanted to slim it down a little bit. You could also write it like that. This isn't necessarily something we've talked a lot about. We did mention it when we first introduced the return statement. When we hit a return in a function, that function immediately ends. It's over right away. That means if I got inside of this if statement and I returned right here, I will never get to this line. Okay, so if I survive this, almost like a minefield type of situation, you know, if I didn't hit this mine and I'm still kicking here, I'll just go ahead and return num2 because that's my alternative. All right. Now, I would say that it's never incorrect to just verbosely throw the else in there. It's just not always really required. But if you're more comfortable looking at this and saying, look, if this is true, do this. If this is false, do this. And that's where we have that else. Cool? So I'll leave this as, we'll call it the preferred result, something like that. That was 9. Okay. And then lastly, what does the following function do? This was the one I think that actually got, I want to say this one did not really get indented funny, did it? Or were both mine left justified? I don't necessarily remember, but this is the one that gave me the wonkier results. So I accepted several different kinds of results for this one, but what does this function do? So it takes in 2 parameters. I've named them S1 and S2. You might say that those are probably strings. One thing that I did tell you before the exam is I'll never try to trick you. So I would never try to have a string that is actually holding, have a parameter actually holding a number, and me call it like string B or something like that. I won't purposely mislead you. I'm naming the functions do something else, just because I'm asking you what does this function do, but I won't give you trick variable names. All right, so S1, S2, probably strings is what I would think going into it, but from a programmer just looking at the code, I'm going to say I have 2 parameters of some type, because we have a loosely typed language, 2 parameters of some type. If we're taking the length of these things, so right off the bat that tells me these guys are collections of some type, right? Strings, lists, whatever, since we've only dealt with strings in class, and I told you I would only test you over what we did in class, it's probably a string. So I'm asking you if the length of S1 is greater than the length of S2. I'm going to return something. What am I returning? S1 plus S2. If this guy's a string and this guy's a string, what operator is this? It's addition if they're numbers. They're not. These are strings. These are 2 strings. I asked if the length of the first string is greater than the length of the second string. So they're strings. Okay, or they're collections of some type. That means that this plus sign right here is the concatenation operator. So I'm going to say I'm going to return, this is if the length of S1 is greater than the length of S2. So I'm going to return the longer string concatenated onto the front of the shorter string. Otherwise, I'll return, what this code does is it returns the longer string concatenated onto the front of the shorter string. If S1 was the longer string, I'll concatenate that onto the front of S2. Otherwise, S2 is either longer or they're the same length, and it doesn't matter. I'll concatenate it onto the front of S1. So number 10. This code returns a string that is the longer of the 2 parameters concatenated onto the front of the shorter of the 2 parameters. So for example, if we had hello and elephant as our 2 parameters, this will return elephant hello. Or similarly, if I had I don't know, race car, something like that, and LOL, this guy would return race car LOL. It's returning it, not printing it. Make sense? All right, questions, comments, concerns, bribes. All right, I'm going to look through the book a little bit, and I might give you a reading assignment for next class. It'll be a short one. It won't be like do the whole chapter. I just want to see where we left off. because we're going to start working with lists and sorting and things like that coming up here pretty soon. So I want to see what you've already read and what you haven't. All right? I will see everybody on Wednesday.